Hello, my name is Jonathan Crabtree from podometic.com, or if you're in India, podometic.in. In the last few days, a maths problem's sprung up on the internet, as it seems to do from time to time, and as you can read here, Mum baffled by question in 7-year-old son's maths homework. And yes, that's really my finger. Hello, how you doing? So, if we scroll on down, we can see here's the problem. A mother put up a problem on Facebook, and as often seems to happen these days, it's gone viral, as they say. Some people might even go so far as to say it broke the internet. So if I just tap on another tab, you can see it's also here on the Sun website. Numbers up, desperate mum begs for help with her 7-year-old son's maths homework, and even a professor can't understand it. That's right, somebody with a mathematics PhD has not been able to understand this problem. So I thought I'd do a very simple video so you will understand exactly what's going on. So let me remove my laptop computer, and I'm going to open up my toy box, which is my base 10 pack. And this is the sort of, these are the sorts of manipulatives or toys that children will use in the classroom. So here we've got a whole lot of jumbled lots of, that's 100, and that's a 10, and that is a unit or a 1. So let's have a look at what the problem entails, and I've just zoomed up the image a little bit. So here we've got, Karla says, I have 3 hundreds counters, 17 tens counters, and 16 ones counters. And the more difficult of the two questions is, can she make 2 equal 3-digit numbers if she has to use all her counters? If so, draw the counters to show them. Well, because I'm a mathematics person, I'm not going to be drawing them. I'm going to be playing with them instead. So, what's Karla got? She's got 3 hundreds. So, I've already prepared these just to save a little bit of time. So, Karla has got 3 hundreds. There they are. That's 100 units, 100 units, 100 units. And she's got 17 tens counters. So that's 1, 2, 3. In fact, I'll put them like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, 16, and 17. So there are the 3 hundreds counters just here, and we've got the 17 tens counters, and we've got 16 units or 16 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they're all of the toys or the devices or the manipulatives that Karla has. And what she has to do is to make 2 equal 3-digit numbers, and she has to use all of these. Okay, so all we're going to do is we're going to do what any child would do. We're going to create 2 equal collections from this set of manipulatives. Now I'll just put something down to divide the 2 sides, and what better than a ruler. Okay, so we've got to have equal numbers on either side. So the first thing that we can do is put 100 on either side, and we're just sharing out. So we've put one there and one there. In fact, what I'll do is I'll do it this way. So now we've got 110 on either side, 120 on either side, and we've got 130 on either side. And this is the first time I've done this video. Just sharing on either side. It's exciting. I might need to put some music behind this. So we've got 1, 2, 3, 4, 5, 6 there. 1, 2, 3, 4, 5, 6 there. So that's 60 and that's 60 because we're counting out the tens. So we're still just dividing them up equally, either side. And there we have it. And we can't keep on dividing them up equally anymore because we run out. So we've got 100 up the top here, and we've got a 10. Now we've got to divide up the units, or the ones, on either side equally. And we know we've got 16 ones, so that's just going to be 8 each side. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, and 8. But, okay, so that's even either side. So what have we got so far? We've got 100, and then we've got 10, 20, 30, 40, 50, 60, 70, 80. We've got 180, 1, 2, 3, 4, 5, 6, 7, 8. So we've got 188 either side. But you don't really need to even focus on that. All we're going to do is we've got left over 100, and we've got 110. So let's just put them on either side. So we'll put 100 on that side. So that's got 100 too many compared to this side. And we'll put a 10 just there like that. That means this side has now got 90 more than this side. Why has it got 90 more? Because I put the remaining 100 on that side and the 110 on that side. So that's got 90 more than this side, because 100 minus 10 is 90. Okay, so this has got 90 more. So imagine if we said, well, really, we've just got to split that in half. Instead of that having 90 more, if we take 45 off there, and we put 45 over there, then they'll be equal. So let's do that. So let's see, 1, 2, 3. Sorry, we've got to do 45. So we've got 1, 2, 3, 40. So we put that over there. And then 1, 2, 3, 4, 5. We put that over there. And now, that's the answer. So we've got 100, and then we've got 200s. So we've got 200, and then we've got 10, 20, 30, and 40. So we've got 200, and 1t, 2t, 3t, 40, 43. 243. And so over here, do we have 243? Well, we've got 100. And I'm going to take 2 of these and make this 80 into another 100. So that's a little bit off the screen. So I'm just going to move that over a little bit. So we've got 100 and 200s. And we've got 10 or 1t, 2t, 3t. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got 10 units, and that makes a 10 all by itself. And we've got 3 left over. So we've got 100, 200. We've got 100 and 200. We've got 1t, 2t, 3t, 4t, or 10, 20, 30, 40. And we've got 10, 20, 30, 40. And we've got 3. And we've got 3. So that's the solution. We can solve the puzzle. We can have 2 equal 3-digit numbers using all the counters, and we've got 243 on either side. I hope that made a bit more sense to you. It's not surprising that a maths PhD can get confused by that, because it makes much more sense to see mathematics and start off with an empirical approach before we get all abstract. So there we have it. We've just shared out the numbers equally as a 7-year-old might learn. This has been Jonathan Crabtree from podometic.com. Thanks for watching.